Okay, imagine this for a second. You're living, say, 3,000 years ago. The sun's gone down, and a thick layer of clouds has just completely blotted out the sky. You need to know what time it is. So, what do? The sundial's useless, obviously, and you can't see a single star. Now, this wasn't just some minor inconvenience. For ancient civilizations, this was a huge fundamental problem.
So today, we're going to dive into the absolutely brilliant solution they came up with. An invention so powerful, it literally reshaped society, science, and even religion. We're talking about the water clock, or, as the ancient Greeks so beautifully put it, the clepsydra, the water thief. But to really appreciate just how revolutionary the water clock was, we first have to get a feel for the world it was born into. A world where, honestly, people were totally at the mercy of the sky just to tell time. Yeah, this table really lays out the big challenges they were facing. I mean, the sundial was humanity's first great clock, and it was amazing, right up until the sun went down or behind a cloud. Then you had the sandglass, the hourglass, which was a decent step up, but it only measured one fixed chunk of time. If you wanted to measure an hour, you needed an hourglass. A different amount of time? Well, you'd need a whole new sandglass for that. And candle clocks? Cool idea, but a little draft or some bad wax, and your timing was completely shot. You see the problem, right? None of these were reliable, continuous, or precise enough for a civilization that was getting more and more complex. And this is where our hero enters the story. An invention that did not care if it was day or night, sunny or stormy. An invention that could finally measure time around the clock. The Greeks called it the clepsydra, which, as you can see, literally means water thief. And it's just the perfect name, isn't it? The clock works by stealing water, drip by steady drip, from one container to another. And in that relentless, constant theft of water, time itself gets measured. This was the absolute game changer. For the very first time in history, people had a reliable way to measure time that was completely independent of the sun and stars. This device basically untethered humanity from the sky, and that allowed for a whole new level of organization and precision, 24 hours a day. And you know what's so cool about this? It wasn't just one culture's brilliant idea. As you can see here, it was this parallel tech revolution happening all over the ancient world. You've got Egypt, around 1500 BCE, where an official named Amen-Humad gets the credit. Then, halfway across the world in China, by the 11th century BCE, they already had a formal government job, the kettle-minding official to manage their water clocks. And then later, the Greeks picked it up and ran with it. It was an idea whose time had literally come. But, just coming up with a basic idea, that was just the start. The real story here is the relentless, centuries-long quest to make it better, to turn a simple dripping pot into a machine of incredible complexity and, more importantly, accuracy. So let's start with the basics. The earliest water clocks we know of, like the one they found in the Temple of Amun-Re in Egypt, were what we call outflow clocks. It's a really simple, elegant design. Just a stone pot with lines marked on the inside. Water drips out of a tiny hole in the bottom, and you just watch the water level drop past the marks to see how much time has gone by. Simple. But there's a big problem with that simple pot, a fundamental physics problem, really. As the water level drops, the pressure at the bottom gets lower, so the water starts to drip out more slowly. That throws the whole clock off. And this is where Chinese engineers did something absolutely brilliant. They created these multi-stage systems. Water would flow from a big source kettle into these middle compensation kettles, which kept the water pressure perfectly constant before it flowed into the last pot. This was a massive leap forward in accuracy. At the same time, over in the Greco-Roman world, engineers like Cleomenes of Alexandria were taking this to a whole other level. I mean, they weren't just measuring time anymore, they were showing it off. They started adding gears to move dials and pointers. They built these clever feedback loops that automatically kept the water flow steady. And then they built these incredible automata, clocks that didn't just tell you the time, they announced it with ringing bells, opening doors, and little moving statues. These were, no joke, the smartwatches of the ancient world. And the peak of all this innovation is just mind-blowing. In the year 1088, a Chinese genius named Su Song built an astronomical clock tower that was 9 meters, that's about 30 feet tall. It was a water-powered masterpiece of engineering that didn't just tell time, but also tracked the stars. This thing wasn't just a clock, it was a cosmic engine. So we have this incredible technology, but the real question is, so what? What did it actually do? How did having a reliable clock for the first time really change the world? Well, the answer is it changed everything. This chart here gives you a pretty good snapshot of just how far the water clock's influence spread. It wasn't just locked away in some lab. It permeated every part of society. From sacred rituals and temples to the chaos of the marketplace, standardized time brought a whole new kind of order to the world. So, one of the first and most important drivers for this tech was religion. In ancient Egypt, for instance, priests had to perform super specific ceremonies at very precise times, even in the dead of night. The water clock made that possible. It meant the sacred rites could be done perfectly every single time, which they believed helped maintain the order of the entire cosmos. Then, the clock's influence starts to move from the temple out into the city's streets. In ancient Athens, they used water clocks to time speeches in the law courts. Why? To make sure both the prosecution and the defense got the exact same amount of time to speak. It was about fairness. And in the massive markets of cities like Chang'an in China, the day was divided into periods marked by the clock, standardizing business hours and creating a much more predictable and fair economy. And maybe its most revolutionary impact of all was in science. For astronomers, being able to accurately measure time day or night was a superpower. It let them meticulously track the movements of the planets and stars, which led to way more accurate calendars, better models of the solar system, and a much deeper understanding of our place in the universe. But the water clock wasn't just some cold, practical tool. It really captured people's imaginations. The Song Dynasty poet Wang En-shi described the water inside one as golden waves, jade liquid. It just goes to show you that people saw more than a machine. They saw poetry, a beautiful metaphor for the steady, precious flow of time itself. And this brings us to the clock's final, and maybe its most important legacy. Its story doesn't just end with a drip. It flows directly into the story of the clocks we have on our walls and our wrists today. It was the essential bridge to the mechanical age. You can see the evolution so clearly right here. It starts with just a simple flow of water. Then engineers add all this complex machinery, gears, and automata, all powered by that same water. The final step to get to a modern mechanical clock was just to swap out the engine, replace the water with a falling weight or a coiled spring. But the heart of the clock, the gears, the dials, the entire concept of regulating motion to measure time, all of that was inherited directly from its aquatic ancestor. So it's so important to get this. The mechanical clock didn't just appear out of nowhere. It was the final step in a 2,000-year-long process of innovation that started with a simple pot of dripping water. Those incredible water-powered clock towers were, in essence, the grandparents of every single mechanical clock that came after them. And that kind of leaves us with one last thing to think about. Today, we live by the nanosecond. We've perfected timekeeping to a degree the ancients couldn't have even dreamed of. But they experienced time as something tangible, a visible, flowing, dripping thing. As we've gained all this precision, what, if anything, have we lost by turning that river of time into just a silent, invisible number on a screen?